Froggy here, and just going to fill in a little piece of a lecture here for you. Your book has a couple of paragraphs that is something like what is climate change or something like that, and then doesn't really provide a whole lot of information about what this is going to be about in this textbook and in this course. And so rather than leave this as sort of a free-floating, we're just going to have some touchy-feely idea that climate change is about the climate changing or some such nonsense. Nonsense in the sense of that's not a useful definition, not that climate change isn't happening. Let's actually invest a little bit of time in making sure that we're clear about how climate change fits into the context of other terms you may have heard of, like global warming or greenhouse effect or whatever. So let's kind of get this all sorted out as to what we mean by climate change. Well, okay, if we have this idea that climate change is about like the temperature changing over periods of time longer than weather or something like that, one issue that you could ask is, well, what about the seasonal cycle? I mean, going from winter to spring to summer, is that climate change? Well, your book strikes out, the kind of interesting a position that I guess that is a type of climate change. I'm not sure I would agree with that, but your book certainly seems to say that that's a type of climate change, not what we're learning about in this book. The seasonal cycle is a very important subject in atmospheric sciences. In fact, in ATS 113, we spend a fair amount of time in the first module learning about why the seasons happen and the changes that they bring and so on. But I would say that is, well, it's important and it's interesting. It's just not what this course is about. This course is going to be about longer-term climate change. Not just seasons, which are just caused by the tilt of the Earth's axis and so on, but changes that are being driven by either natural processes or processes that are being caused by human beings. And in order to do this, we're going to need some kind of good definition for climate change. And I have to admit, before I wrote this lecture, I wouldn't have thought that was so hard. Turns out, boy, almost all of the definitions that I could come across for climate change were just way too technical and wonky, or way too glib. I mean, we had that first problem. Remember back in the first main lecture that we had about weather and climate, we kind of had the same trouble defining climate. With a little bit of doing, I did come across this definition from, this is a European Union education office that actually seems to have a pretty good, useful definition for our class, and that is climate change is the long-term change in the statistical distribution of weather patterns over periods of time that range from decades to millions of years. When they talk about weather patterns, now, we could be talking about a lot of the large-scale, what meteorologists call general circulation of the planet, how areas that have deserts are moving, areas that are experiencing rainforests are moving, etc. More to the point, though, in terms of what this course is, when we talk about temperature, when we're talking about like weather patterns, we're talking about like the temperature you would expect. Most of this class we're going to be addressing issues of temperature, although we will also talk about how that has ramifications for, say, precipitation regimes or even wind regimes or cloud cover regimes or something like that. But mostly we're going to be talking about how temperature is changing at locations. And I do want to point out that this particular version of the definition of climate change is certainly not stressing whether there'd be any difference between global climate change, like the whole planet is getting warmer, or regional climate change, like maybe how California is becoming drier as part of a long-term drought, or the Dust Bowl years of the 1930s, or how ice sheets are retreating in the Arctic right now, or something like that. There are regional climate changes, and there are also global climate changes, and obviously both of them are very important. Typically the regional climate changes would be just the local manifestation of a global change that's going on. Locally the temperatures might be increasing more. In fact, that, as we'll see, turns out to be the case. Temperatures are changing more near the poles than they are changing in the mid-latitudes where Omaha is found. Notice that this particular version of the definition of climate change didn't bother mentioning whether it's talking about natural climate change or anthropogenic climate change. Let's actually spend a moment here on that word anthropogenic. I like that vocabulary word a lot. Anthropogenic means caused by humans or originating in human activity. Anthrop, man, genic, gives rise to. So anthropogenic climate change would be climate change that's being caused by things that human activity is doing. Like burning of fossil fuels would be the obvious one. although there can be others, as we'll be seeing over the course of the semester. But when a process that is a result can be anthropogenic, it is caused by humans, in contrast to being a natural climate change. Both happen, okay? I mean, for example, you go back 20,000 years or so, most of North America was experiencing a very, very serious ice age. We're going to be learning a lot about the climate of the past in future modules of this course, but you know darn good and well that, much of the Midwestern United States was under ice sheets more than a mile thick if you go back like as recently as 20,000 years ago. This was not the only time there was an ice age in that part of the world. It just happens to be the most recent one, the one that we tend to be most interested in the sense that that's when woolly mammoths and saber-toothed tigers and stuff like that were in North America. But, I mean, obviously, humans didn't cause that ice age, and humans didn't cause that ice age to be over. Okay, so clearly there are natural mechanisms by which climate can change. Just to give you another example, this is just an artist's depiction of the world of the Eocene. The Eocene was a geologic period, about 50 million years ago. After the dinosaurs were extinct, there was a period where the climate of the Earth was very warm and very uniform. There were roughly the same temperatures at the equator as, say, at the latitudes that something like Greenland is nowadays, okay? Goodness, how do we know that? Well, we'll be talking about that when we learn about paleoclimate, the climate of the past, in a future lecture. And this particular event of the climate of the Eocene, we're going to be learning about, I think it's chapter 7 of the textbook. But I mean, clearly, humans didn't even exist yet. Obviously, we are not responsible for that warming. Interestingly, the amount of warming that was experienced during the Eocene is due to an amount of carbon that was released into the greenhouse gases, let's be more generalized than that, of greenhouse gases that were added to the atmosphere, similar to what humans are adding now. I don't know that we want to have a climate that is that warm at, say, Greenland now, as they would have had during the Eocene. So those are natural climate changes, and when we start learning more about the physics of climate, you're going to find out what kind of processes can cause natural climate change. But obviously, if you pay any attention to news and debate and so on, and for that matter, just being in this class, you know that the kinds of climate changes that might be due to human activity, the anthropogenic climate changes, are the ones that we're very, very much worried about. And sorting out the differences between ways in which the climate might be changing naturally from ways in which humans may be affecting the climate is a key issue in climate research. And it is a key debate that is the kind of thing that a certain type of radio host, a certain type of blogger is going to be trying to complicate to make it seem like this is less settled science than it really is. But regardless of how the climate change is happening, whether it's caused by changes in solar output or changes in the Earth's orbit, very natural causes like that, or if it's caused by the adding of greenhouse gases to the Earth's atmosphere and creating a warmer planet, regardless of the way the climate is changing, we use the word climate change to describe it. Okay? It doesn't matter whether it's anthropogenic climate change or not. Now, to sort that out from another term you probably are familiar with, let's talk about the greenhouse effect. Now, in the background of this picture here, I've got a greenhouse. We're going to learn in a later module that greenhouses have nothing to do with the greenhouse effect, or the other way around would be a better way to put it. The greenhouse effect has nothing to do with greenhouses. But you know what I'm talking about when we talk about the greenhouse effect, at least in broad ideas. We'll learn about this a great deal in coming units, but clearly you know that there is this idea that gases in the Earth's atmosphere help keep the planet warm, possibly keep it too warm. This is a perfectly natural phenomenon. All planets that have atmospheres have a greenhouse effect that is greater or less depending on the constituents of their atmosphere. Venus has a runaway greenhouse effect that is keeping the planet hundreds of degrees warmer than the Earth. Venus is closer to the Sun than the Earth is, but it isn't that much closer to the Sun than the Earth is. The high temperatures that are warm enough to melt lead at the surface of Venus are caused by its greenhouse effect. We have a greenhouse effect on Earth. Earth is pretty far from the Sun. If we did not have an atmosphere on the surface of the Earth would be much too cold to support life. Of course, if we didn't have an atmosphere, we wouldn't have life anyway, but you understand what I'm saying. We are pretty far from the Sun. Earth would be a frozen dead rock if it weren't for the greenhouse effect. The greenhouse effect Again, we'll learn more about how it works and so on in a future unit, but it is a very necessary and important aspect of how Earth's climate system works. And we have probably been messing with it. The so-called enhanced greenhouse effect has to do with the fact that the greenhouse gases in the Earth's atmosphere, the list of such gases include the kinds of things that come out the tailpipe when we burn fossil fuels in our cars. Gases most notably like carbon dioxide, although there are others, that enhance the greenhouse effect. Again, we'll learn the details about how the greenhouse effect works and how adding more carbon dioxide enhances the greenhouse effect in a later module, but just I want so that even here in this very first module, we know how to use these terms right. The greenhouse effect itself is a perfectly natural and necessary phenomenon. The problem is we are enhancing it by adding additional greenhouse gases to the Earth's atmosphere, primarily through the burning of fossil fuels, although things like deforestation, for example, are reducing ways we get those gases out of the atmosphere. We'll learn all about the carbon cycle in a future module, but this is where we're going with this, is this idea that there's this enhanced greenhouse effect. The ways in which we have increased how the greenhouse effect works is affecting our climate. Now, putting this together then, there's also global warming. Okay. Global warming is this idea that yes, there's some places that have warmed more, there's some places that have warmed less, there's probably even some places that we could measure where the temperature has actually decreased, but taken as a planet, the observations show that the planet is warming. That's where you see things like these diagrams right here. Now, these diagrams, we're going to learn more about how we determine whether or not the planet is warming. These happens to be based on actual records of surface temperature from official weather stations on the surface of the Earth and in buoys over the ocean and so on over very long periods of time. And you can see how the temperatures have gone from below the long-term average in the 1880s and 1890s to much above the long-term average in recent decades. There are people out there who deny that global warming is happening. I kind of like to follow crazy news blogs out there. I have a real affinity for that for some reason, some kind of personal punishment or something. But there's a certain type of journalist, blogger, radio host who tells you that the planet isn't actually warming. This is all something that the scientists are faking the data. We'll talk a little bit more about all that kind of stuff in a later module, but this idea that the planet is getting warmer, there's a certain type of writer, journalist, blogger, host on the TV, whatever, who doesn't believe in this. But by and large, that is a settled science. I mean, even the scientists who doubt that humans are causing climate change don't in general doubt global warming. By and large, this is less the issue when scientists are trying to sort things out. I think realistically all climate scientists agree that the planet is warming. There may be differences. There are these folks that we've talked about that are opposed to the idea that humans are causing it, but we'll sort that out over the course of the semester. But all of the observational evidence seems to indicate that the planet is getting warmer. That is global warming, which is a type of climate change. It's a global climate change, and it might be due to the enhanced greenhouse effect. We'll have to decide, how did science come to the conclusion that that humans are what's causing this? Okay, but we'll get there. But this is what we're talking about when we're talking about global warming. And it is a big widespread phenomenon. Just to show you, for example, these are the official analyses of the land and surface temperatures for the fall of 2015. Just to give you a sense here. Now, the key here has, different colors are representing like the record coldest, the much cooler than average. Each of these, there's a scientific definition for, okay? We're just looking here at kind of a visualization of it, but I mean, how much colder than normal is that middle blue color? How much warmer than normal is that middle red color, etc.? That all has a definition. We're just not in this visualization seeing it. And by the way, that darkest red color that covers a whole lot of the world is the warmest on record. A whole lot of the Earth had its warmest September, October, November ever. In fall of 2015. And wow, that is a big chunk of the world that's having its warmest ever at this time. Okay, so we have a lot of different types of observational data that is showing that the world is getting warmer. The global warming aspect of it is in general no meaningful debate, okay? I mean, I suppose if you write for drudgereport.com or something like that, you think that there is, but even scientists who don't agree that humans are causing the global warming agree that global warming is happening, okay? So, just to sort of summarize what all of this stuff means here, just so we kind of have it all on our plate at the same time, okay? Climate change is the term we're going to use for any way in which climate is changing. Getting warmer, getting cooler, getting drier, getting more moist, whether globally or regionally, okay? We're not going to worry about why it's happening or something like that when we're using the word climate change, okay? We're going to be describing it, okay? The temperature records at this location are showing this, or the rainfall records show this, or from this paleoclimate data archive based on tree rings or something like that, we can see that this climate change has happened and so on. We're not going to worry about how it's happening when we're using the term climate change. The greenhouse effect is not the same thing as climate change. The greenhouse effect is a necessary, important, and well understood aspect of our atmosphere. Okay? We will learn more about the details as to how the greenhouse effect works in later modules of the course, but this idea that the atmosphere works something like a blanket, or if you want to even say, for at this point in the semester you want to think about it as like a big greenhouse over the earth, okay, that's entirely wrong as to how it works, but that'll suffice for Module 1. It's well understood. It is not as if scientists don't understand how the greenhouse effect works. We have years of observations, we have years of theoretical work, we have years of simulations. We understand the greenhouse effect. Okay? We are enhancing the greenhouse effect by adding greenhouse gases to the atmosphere. The greenhouse gases are things like carbon dioxide and methane and so on, particularly though carbon dioxide, because carbon dioxide is a byproduct of the combustion of fossil fuels, which we burn by literally the gigaton, as in billions of tons. Okay? Huge trainloads of coal, huge tankers full of oil every day. Okay? We are clearly adding enormous amounts of carbon dioxide to the atmosphere. How much it is can be determined, how much it is can be measured, how much it is going to affect the greenhouse effect can be calculated. Okay? This is something that we know. Now, during this whole process, we can also see that the planet is getting warmer. The observational evidence that the planet is getting warmer is called global warming. Okay, the planet has warmed before. It warmed at the end of the Ice Age, the most recent Ice Age. It has warmed a number of different, that's not the only Ice Age in human history. As we're going to learn in later modules, there have been all kinds of climate changes before humans were burning a lot of fossil fuels at the start of the Industrial Revolution. Climate change happens. Global warming has happened before that had nothing to do with humans. But this time maybe it does. What tools do we have that can tell us if the observed global warming is being caused by human activity? Is the observed global warming anthropogenic? So see how we have these ideas here. We have climate change, greenhouse effect, enhanced greenhouse effect, and global warming. These are the 4 ideas I want you to be able to kind of keep straight in your mind as we make our way through the remaining 7 modules of this course. Okay, for this particular lecture, I don't really see a lot of need to put together a list of little questions that then you navigate through on little videos and things like that. So I think that this is fairly straightforward. I think the book does a fine job explaining this stuff. If you have any questions about any of these terms or whatever, I would love to hear from you. Send me email. Please let me know if you have any questions. This has been Dr. John Schrage.